Okay, let's talk about WiredTiger. First off, this storage engine is new in MongoDB 3.0. It is our first pluggable storage engine, and we are thrilled to be rolling it out. It comes with a number of great features. The first is document level locking, our flagship feature in MongoDB 3.0. Another great one is the fact that it brings compression to MongoDB. It also lacks some of the pitfalls of mmap v1. And finally, it gives some big performance gains. Now this is all just in the initial release. We expect more to come as we take advantage of more and more of WiredTiger's features going forward. So let's go into some of the details. Let's start by giving you a little background on WiredTiger. First, it was built separately from MongoDB. It was an independent company that made a great storage engine. It's actually used by other databases out there, and it's an open source project, so you can download the source code if you like, just like you can with MongoDB. Also, just to give you some recent history, we approached them to be our flagship pluggable storage engine. Once we started talking to them, we fell in love. They've now joined MongoDB, and we are thrilled to have them on board. So let's take a look at how it works. First, to see some options, we're going to look at --help with our MongoDB process. If I look here, my first storage option is --storage engine, defaults to mmap v1. If I want to, I can use that to run WiredTiger. Moreover, I've got a number of WiredTiger options. I'll be talking about that in a little bit. But for now, let's check it out. Okay, I'm going to try to run with storage engine WiredTiger. This is going to fail for reasons you're about to see. And that failed. So if I look at the log here, what's going on? Detected some mmap v1 data files in my path. It's a pretty likely mistake if you're trying this out and you already have MongoDBs running on your system that you shut down in order to start WiredTiger. So we need to blow those away. Let's do this. All right, there are my mmap v1 files. Now I've deleted them. Let's try this again. This time I'm going to fork the process so that it runs in the background. Great. So when I look at these files, the first thing that I see is WiredTiger is literally written all over my DB directory. Next thing that I see is that it's got a collection and an index already. Let's see what it looks like when I go into the database. So I've got the local database. My collection must be in there. And it began with the startup log. And when I look into the startup log, here I can see my storage engine. Everything's good, so let's create a new collection. I'll go back to test for this. I don't want to muddy up my local database. We'll start with a simple document. And now I've created a second collection as well as an index for that. First thing you'll notice is that WiredTiger is totally indifferent to databases. It works on the collection level. And that's why you're seeing that. And the indexes you see are the _ID indexes. Since indexes come later in the course, we'll talk about those another time. Now that we've got things running, let's talk some more about it. First, WiredTiger stores its data on disk in B trees, similar to the B trees mmap v1 uses for indexes, but not for its data. And then new writes initially get written to files in unused regions and then incorporated in with the rest of the data in the background later. This actually brings up something interesting. WiredTiger, during an update, will actually write a new version of documents rather than overwriting existing data the way mmap v1 does in many cases. You might think this sounds like a lot of work, but WiredTiger handles it very well. So with WiredTiger, you don't have to worry about document movement, you don't have to worry about padding factor. In fact, WiredTiger doesn't even provide padding. Doesn't need to. Next, WiredTiger has two caches of memory. The first is the WiredTiger cache, which is half of your RAM by default, but you can tune that. And the next is the file system cache. Let's talk about how your data gets from the WiredTiger cache to the file system cache and then onto the drive. This happens periodically at what's called a checkpoint. During a checkpoint, your data goes from the WiredTiger cache into the file system cache, and from there, it gets flushed to disk. It initiates a new checkpoint 60 seconds after the end of the last checkpoint. So roughly every minute or so, but maybe a little bit more. Each checkpoint is a consistent snapshot of your data. If for some reason you were running your MongoDB with WiredTiger, with no journaling, and with no replication going on, you would need to go back to the last snapshot for a consistent view of your data. So about a minute. Also, because it's a consistent snapshot, if you are using journaling, it will truncate the journal at this point. Furthermore, if too much of your WiredTiger cache gets dirty, it will begin flushing data to the file system cache and from there to disk. One thing to note here is that since a checkpoint is a valid, consistent snapshot of your data, you technically don't need to run WiredTiger with journaling enabled. You're guaranteed to have a consistent state of your data from the last checkpoint. And the second to last checkpoint doesn't get deleted until the next checkpoint from that gets fully written. Of course, journaling does keep your data on disk much more timely. It gets written to disk in a much more timely fashion, that is to say. Next, WiredTiger comes with document level locking. We are thrilled to have this here. Technically, WiredTiger doesn't have locks, but it has good concurrency protocols. The effect is the equivalent of document level locking. With WiredTiger, your writes should scale with the number of threads, assuming some reasonable caveats. No trying to have all of your threads update the same document at the same time, for example, and no trying to use lots more threads than you have cores. Obviously, your hardware is still a potential limitation. That said, we are thrilled to be able to roll out this feature with WiredTiger in MongoDB 3.0. Next, since WiredTiger has its own cache, and since the data in the WiredTiger cache doesn't have to be the same as the data in the file system cache or as it's represented on the drive, actually they're quite different, WiredTiger is able to introduce compression. It comes with 3 compression options. Well, technically 2 compression options, or you can run with no compression. These are all open source compression libraries. You're welcome to check them out on your own. The default is snappy, and as the name implies, it's fast. It prioritizes speed, but also tries to get as much compression in as it quickly can. zlib prioritizes compression a little bit more, potentially at the cost of some speed. Contrast this with mmap v1, where the bson needs to be written out on disk, just as it is in memory. So no compression is possible. Okay, now that you have a sense of how WiredTiger works, let's look at some of the options that you can use at runtime. Many of these deal with compression, either of your data, or of your journal, or of your indexes. Index prefix compression, for example, can save some space, but at the cost of some processor usage. You can also select the option to have indexes in a separate directory. You can also tune your cache size in order to maximize your performance. And finally, if you're interested in seeing what's going on with WiredTiger, sort of under the hood, you can also have statistics logging. It's a new pluggable storage engine for MongoDB 3.0. It brings document level locking to MongoDB. It brings compression to MongoDB. It has an improved performance in many use cases, and we're very proud to be able to offer WiredTiger for the first time ever with MongoDB 3.0.